Okay. So today we will be covering the last part of making the structural elements in Revit. That is just creating the PCC below the foundations that we generate initially. Before this, we have covered how we can use CADs to generate the columns, the beams, and the floor slabs. Now, only thing is the PCC. Okay, so let me just run the script and show you what we are trying to achieve. So, under normal circumstances, what we would have to do the PCC is to go and draw the PCC manually for each profile and then give it the appropriate height, because each of the foundations are at a different height. Some of them are lower and some of them are higher. Okay, so the script will take care all of this when it's run. So we specify two things. One, the thickness of the floor, that is the PCC type we want to use, and then the offset, like the offset from the face of the foundation, which is this. So let me run it once. Yep. And you can see it has generated it, and the offset that it sets, it's based upon the existing foundation. So this offset is taking normal automatically, whether it's minus 1000 down or whether it's minus 1500 down, that is automatically set. So even if you have different foundations at different height, it doesn't matter. It also gives the offset from the foundation itself, like this is 100 in this case. So now let's move on to the script and see how it's designed. Yep. So the first thing we need to do over here is to get the foundation elements itself. Okay, so if I switch on the preview for this, sorry. Yeah. So as a first step, what we're doing over here is we are getting all the foundation elements. That is the solid geometry of it, using the like a simple collector for the elements and then getting the element solids. So you can see we have obtained 15 solids for each of the 15 foundations that are there. Okay, and then we are exploding the geometry. You can see we have just taken each of the surface solid cubes and broken down into 6 surfaces over here. So because we were requiring the bottom surface so that we can generate the foundation profile based upon that. Okay, the next thing that we are doing is generating a surface normal. Surface normal is nothing but a vector point which starts from the center of the each of the surfaces. So if I do over here and I draw a line, it will be visible. So the direction is the vector direction. And let me get the point at the same place. Yeah. Number. Yeah. Yep. So what this does is it's generate these lines coming out of each of the surfaces of the foundation elements, as you can see over here. And what is the utility of these lines? The line is this gives us a particular direction. Okay, we will get the coordinates of it. So if I go back to the node view, you can see I'm getting the z coordinate of it. So you can see a number of values for the z. Okay, so the z is the direction of the axis, right? So if I go to geometry view, so I have positive 1 on this side in z and negative 1 on this side. So, so one second. So, yeah. So that's what we are obtaining, the z vector of it. and we are taking all of them which are equal to -1, which is the direction which is down. Okay, so then we are using a simple filter by ball mask to filter out the surfaces and only obtain those surfaces which are the bottom surfaces in this case, because that's what we require. So if we go over here, yeah, switch on this preview. Let me switch off the solids. So what here we have are the flat bottom surfaces of the solids that we had initially. Okay, so what we did was we went from this, which was a full solid, to the bottom surfaces of the solid, so that we can further process it going forward. Okay, so once we have all the bottom surfaces, after that it's again pretty simple. We are extracting out the curves of each of the profile surfaces like this, then putting it into the join by polycurve nodes to get one single polycurve. A polycurve is a 4 curves joint. So we started. Okay, this the PCC had also been taken. Let me delete this. It's creating a surface below another surface. So let me just undo the Dynamo script as well 2 times. Yeah. Now you can see there were 15 foundations and a polycurve exists for each of the 15 foundation. And then we simply, if I go over here, this are the polycurves. You can see. So once we have this step, the only thing that is left to do is to offset the curves out. So we are going to be using the curve.offset node, the input of which we provided at the very start. So this simply offsets all of them, like joined together on every sides. So this was the reason we did the polycurve before offsetting them, because if we didn't use polycurve over here and put the curves in directly, if like this, let me freeze this node. We do not want the float to be generated. So this is how it would have gotten offsetted. Okay. And see, there is no order to this, and we won't have not been able to work with these points after offsetting. If we offset the curves individually, there would have been gaps and everything. So in order to avoid that, we use the polycurve by joint curves to get clean curves, which we then could offset a specified distance. Yeah. Again, something got created. Okay. Let me undo. Yeah. So this we are the final step. So post this, we are simply inputting the curves that are generated finally into the Revit floor by outline option, which is this. And once more, yeah. Okay, too many of these foundations are being generated. Let me undo all. Clean up the. Yep, let me just run it for this. Yeah, and in the final step, each of the floor is fed into this from over here, and it generates the surfaces of it automatically. Okay, this is the float type it is being specified, which is PCC 100, and then the offset of it. And so that creates this element over here, which itself is a foundation slab. That was it. Like, how do we generate foundations from the bottom? So that completes the topic that we covered this week, is how we can use Dynamo to generate structural elements within a building, like from a CAD model go into a Dynamo model. So if anybody has any queries or any questions, we can discuss them now. It can be non-related to the presentation also. It may be in general about automation or any queries. If anybody would like to share the screen or any solutions that they would like to discuss. Yeah. Uh, Abed, are
Hi.
you saying something?
Yeah.
Yeah. Hi.
Yeah. Actually, if you go back to the note, uh, I I actually didn't get from the beginning this one. Can you just explain a little bit further? Because uh,
So what we're doing over here is we are taking the all the foundations as the first step. Okay. So if I go to, like, let me know whether you got the first step, which was getting all the foundation solids as the first step, which is this.
okay,
Okay. So once you have done that, we are moving on to the next step, which is just flattening it. So we have this as solids. If you see over here, each of this, we have
yes,
15 solids for 15 foundation elements. So in the next step,
okay,
what we are doing is we are splitting it into surfaces using geometry explode. Okay. So
okay,
we have a number of surfaces, but we don't know which is the bottom surface and which is the top surface. Right.
okay,
So
yes,
there, what we are doing is, if you take, wait, let me show you. So the logic is
with surface, okay,
we are creating a normal, which is nothing but a vector at a point. Let me get
okay,
um,
the list item get index,
oh, I'm just gonna take a single item to show you the logic
okay,
of what this happening over here, and the same thing is happening for all of them over here. So the logic will be the same. High geometry preview. Yep. Yeah. So now we have one cube, and this one cube has a
mm-hmm.
number of surfaces, right? So if I
Yeah,
do, so now if you see what we are doing over here is we have a list of surfaces over here, like
yes,
five surfaces, six surfaces. So we
yeah,
don't know which is the top surface and which is the bottom surface, right?
yeah,
But we only require the bottom surface for our task. So what we did
okay,
is we generated a vector, which is nothing but a point and a point which points to the outer direction of it. So
mm-hmm.
if I put this in, like I'm just taking one item at a time and seeing the vector. So you can see this gives a direction x, y, z,
Yeah,
0, 0.
X Y
Okay.
Z, yeah,
Length. So normal vector is nothing but a unit length vector. Okay. Unit length means the length of one.
mm-hmm.
So if I go through this entire list and check all of their vectors, let me add a watch node over here. So a vector has three components, x, y, and z. And z is the component which
okay,
is either pointing up or down, right?
okay,
So if I make this larger, so you can see I have the z values. So z values for the surfaces which are not pointing either up or down will always be zero,
yes,
right? or
Yeah.
very numbers which are near to zero because of some coordinates mismatch, like geometry not being rendered properly. So what we did is we got the z
Yeah.
value of only them, which is this. After updating, we are getting only the z component of the vector. Okay.
Z components.
Yes. So once we got the z component, so if we put it over here also, let it run. So the z component is like this. Okay, only one number one is the value that matters, because we know the negative minus one is the number which is the bottom. So what we are doing over here
Bottom.
is
Yeah.
we are asking it to check whether it's number one or not, whether that value equals to number one or not. Okay.
Okay.
So when we do that, so it will give a true for only one and a false for all the others, right? Because only
All
one
others.
surface
Yeah.
is pointing downwards. Yeah. So
Okay. Great. So
so
now our input.
so for this one surface when we are running, we are getting a list of trues and false, whether they're equal to minus one or not. So you can see
Okay.
all of them are false apart from number four, which is actually minus one,
Minus
right?
one. Yeah.
So now that we have this, no, we know that the number four is the one that we need. We are using a filter by Bol mask to filter it.
Okay.
Okay, we are using this to filter out all the surfaces that we obtain in the first step, which is
Okay.
this. Okay, so now if we filter out, only one of the surfaces will come as true. So if I go and put a watch node over here, so only
So
one
all
surface
minus
comes.
one. Yeah.
Yeah,
All surfaces at minus one.
yeah, it's getting all
It
the
it will
surfaces which
filter out.
are, yeah. So apart from all
Fine.
surfaces which are not at minus one, it got filtered
Hmm.
out. So that's how we obtain the bottom surface of the, like what I did for this. That's the same applicable for
For
what we say, the
for
all the other
for
surface. Yeah.
groups. Yeah. For the
So now if I put this over here, this will be the only surface that is visible. Let me. Okay, again, it's the only problem is if you already have foundation elements generated, it will run on top of those foundation elements. So,
ah.
so this is the surface that we got. Okay, like the bottom surface, and that's what we are using to generate the rest of it. Like from the
Okay.
solid we have over here. If I want the PV, so this was the full surface, and that was the bottom that we had over here. So the entire process is just to filter it out and get to the bottom surface, like to detect it. And the same thing we are doing it for all the surfaces with this node. We are just doing the equal to, like I showed, then using filter by Bol mask
Yeah.
to filter out the surfaces. So once we have the surfaces, the rest of it is just getting the outer periphery of the surfaces, joining them together so that we can offset the curve while maintaining the connections between them. Okay, like joining
Yeah.
the curves, offsetting the curves, and then just creating a floor with that outline. Mm, is it clear? Or
Yeah. Yeah. It's clear. It's clear.
sure,
I will look at the script again. So
sure.
it's
Yep.
it's clear. Thank you very much.
Yeah.
Thank you.
Thanks.
Thank you.
Thanks. Thanks.
Thank you. Actually, today we face one issue in the office.
Yep.
Uh, we have a tunnel model
Yes.
which we extracted from the Civil 3D corridor.
Okay.
Okay, I will share my screen.
Sure.
your entire screen. See this this model we extracted from Civil 3D, and here I will show you as a family. We create as a generic family,
Okay.
like top slab of the tunnel and right wall, left wall, and the bottom wall,
Hmm.
bottom slab. Sorry. So we face one challenge here, like wherever we have the node of five, wherever we have the endpoints of the
Hmm.
tunnel or solid is sliced, there we will get the endpoint and we will have elevation and coordinates
Hmm.
of it. Wait, I will open the plan. So, like uh, here, if we draw something, a line here,
Hmm.
and we want the coordinate and elevation at this point.
Okay.
Okay. See, when I snap it, actually it's snapping to the line. So that's why it's not giving an elevation.
Okay.
So, but we need the elevation in the middle.
What if you try the corner of it where the edge is there?
Corner, yeah, corner is working. But when I get
Okay.
the
Tab.
end
Try
point of
clicking
the
tab. Tab is not working.
yeah, actually tab is snapping to the solid. Okay,
Okay.
it will work. But whenever I move to the end point, it's not giving an elevation.
Okay.
So we just it's kind of jugaad. Actually,
Understood.
we just did like this and then approximately move it here somewhere.
Got it.
Yeah, we did like
I
this.
understand the problem because it's
Yeah,
not broken. That edge doesn't exist in anywhere else. It's not picking up that point.
yeah.
Mm.
But is there any solution to model the tunnel inside the Revit?
I like. I don't have anything from the top of my head
Uh,
that will solve this problem of
uh,
yours.
uh,
Uh, what you can do if it's broken down into sections, okay? Like
yeah.
normally there are RCC sections, right, which make up a tunnel.
E, yes, yes. That's why
So,
we added the expansion joint, and
uh,
like this one
so,
is a expansion joint
hmm.
location.
So what I'm saying
So
is you have the path in of the tunnel, right? Why
yeah,
not put it in like what when I have done a few, but in that tunnel, what we have done, we have done it piece by piece. Like a number of pieces have been joined together to make that tunnel. RCC
hmm,
pieces which
yeah.
stack one after another to make the column. That is one thing, but you're this particular, yeah, if we take that line and say give the heights at a particular interval, that also information we can obtain. But
But everywhere I have to select the line, and there is no height for this line.
like
There is
you
no
can,
property.
I understand you are getting it for
Uh,
the entire slope. You're not getting it for a point because
yes,
that point
yeah,
doesn't
yeah,
exist.
yes, yes.
So one that I was saying is if we like when we if we can recreate this, like take this object and then split it and then recreate it so that that point exists, or split this into small sections. Like with Dynamo, we can
Actually, at
split it
this,
into a number of small sections, say at 500 or
hmm,
1,000 difference. That maybe we can try.
yeah,
But again, I'm just thinking out loud. Not sure what will work.
yeah,
Yeah.
yeah. Actually, the problem is we have submission, so uh,
No,
we
for
don't
like
have time. If we
I don't.
slice it, I
I
we
understand.
if
Like
we slice yeah, if we slice it now, all annotation will gone.
yeah, that's too risky, and you cannot
Yeah,
experiment
yeah,
with something in
yeah,
this
yeah.
way. Yeah.
I got you. Mm,
I
okay,
think
thank you.
Afzal wants to say something. Yeah.
Yeah.
Yes, sir. This is Afzal.
Yeah.
Sir, I have a similar question. If this tunnel, I need one line from start to end line, start to
Okay.
end. How can I make this?
I did not get you. Like, we'll start to end one line to do what?
Sir, they have this tunnel, one start point and one is end point.
Huh? Okay.
So I want to make one line from here to there. Then I will convert this line to pipe through Dynamo.
So,
Actually, Saurabh, can I
yeah.
explain?
Yeah.
Actually, we have tunnel in slope.
Okay.
Okay, and we have top slab, we have bottom slab.
Yes.
So they have utilities inside the tunnel.
Okay.
Okay, and they have an offset. For example, here, if I draw something here, they have their pipe is running inside the tunnel, like 200 from the
Yes.
face of the wall.
Okay. Got it.
So they want a top edge of the tunnel, and then they will make offset from the bottom slab or side of the wall to run
Okay.
the
Got.
pipe in the
Got
same
it. Got
slope.
it. Got it. So what you're talking about is, wait. Let me just share my screen. Tell me if I'm
Yeah,
correct or
please.
not. Uh,
Right, Kamran? This was your question, right? Actually, me and Kamran working in the same company.
Yes, Abid.
okay. Okay.
Thank you.
So just
Thank you.
saying there, the slab is like this, and say it's a slope
Yeah,
slab
yeah.
going like this from here to say a slope of 18 degree. So the goal is,
Like you can say, we have two slopes, one at the bottom and one in the top. So
hmm,
you can get one is at level one and another one same slope, but at a different level.
so so now you're saying that if you have a slope like this, how do we draw a pipe which is parallel to this, right?
Yes.
Okay. Like just a thought. Maybe it will work. Maybe it won't work. But
Okay.
how
Okay. No problem.
how I am thinking
Maybe
that it
maybe
will.
we'll get an
Uh,
maybe we'll get an idea that how can we.
what I would do is select the face.
Element selection of face.
Face to get the surface of this, say the bottom surface of this,
Yeah.
and select H to get the start and the end point.
Yeah.
Then what I will do is I will get this points over here, and then I will just get the center point of that curve point. point. No, I need the curve point at parameter geometry curves. Hmm. So what I will do is I will just get the center point of the curve. I can get anything that I want, but here just for simplicity, I'm getting the center points. Coordinates. Or I can use a simple move command also. Move So we have two geometries and set.
Direction Z.
Yeah, like which direction we want to move it, because we wanted to move
Yes.
it another
Yeah.
Z direction.
Mm-hmm.
So and the distance, say we want to offset it from the surface by 500.
Like say 4 meter or okay.
Yeah. So this number we can change.
Yeah.
Like now, if I draw a line, so we have the line,
Mm. From this
and we
line
want to move it down, so it will be minus
down.
negative minus 5.
Yeah.
So we should, if I go to geometry view now, so we have the
Now
line,
we have the center line.
uh, like centrally it's going down, but we can move it using that. And then I don't know, pipe. I, I have not generate a pipe from that. I think if we have element, so I know that we can generate the curves like this. Now I have to see whether we can generate a MEP element like a pipe like this. There must be a option to generate pipes as well. Like if I'm generating the framing of this file only, framing type. That's okay. So we got the curve, but I need to do a proper pipe with it, or else it. So, mm, so if I go back and type in say ducts, this this I have to see creating MEP elements, get ducts or pipes. Like this, I don't know the node to create a pipe. This I have to check and get back, like exactly which node can generate a pipe, but to
Kamran, you
offset.
tried already to create a pipe from the curve. Which node you are using?
So that I am not aware of which node to use to
No, no.
create a
I'm
pipe.
asking Kamran actually.
Yep.
Is there is a node to create the pipe?
Yeah, where I can find that node, if he can tell
Mm,
me, because I don't see one over here. close and create model curves.
Actually, what we did, we
Hmm.
get these curves from the Civil 3D and the create the pipe.
Yeah, so these curves can be generated in Revit also. Like you can see this
Yeah,
curve is
yeah.
there, but we need a
This
node
is the good idea.
which will take this curve and then generate the pipe. So
Uh,
I don't have that node with me. Like I have to search for it. Exactly.
I also don't remember
Huh.
exactly
It
what
will
was the
be
node.
somewhere. Yeah, but um, if you know, like somewhere it will be. I think under Genius Loki, it's only there. But
Uh, Let me
MEP,
check here. PIP. Actually, there is one package for MEP or
okay.
pipe.
Like yeah, I have to check it out
Email.
and get back whether we
Yeah.
can create the pipes
Okay.
or not.
Thank you.
But it yeah,
Yeah.
you can try this if you then after that use the node. Like just take the edges and take the midpoint and from there move on. Yeah.
No, no, this is a good idea, Yan. We minimum get the idea how we'll generate the curves in Revit itself, and then
Yes.
we will.
Yeah.
Can you
Try
please
it.
share this? Can you
Sure.
please share this? Thank you.
Yeah.
Share. Uh, Share the script so
Sure.
we will
Sure.
try further, and I'll send it back to you as well.
Sure. Sure.
Sure.
Yeah.
Thank
Post
you.
this.
Thank
You can post this kind of challenges in the Dynamo forum itself. They will
you.
solve it. It's pretty active.
Actually, a problem is for the building, and we will get many things, but for the linear structure, it is difficult to find
Yes, because it is
the
in for
solutions. Yeah.
building. It's there for a long time, right? Dynamo.
Yes. Yeah.
But Civil 3D, I think it came much later.
Yeah.
I'm saying you can post it in the Dynamo forum because that's pretty
Yeah.
active
Sure.
and that
Sure.
way users will
I
yeah.
I do. I do.
Yeah, I will share this. Not an issue. Yeah. Thanks.
Thank you very much. Thank
Thanks.
you. Thank you very much. Thank you
Thanks.
for your time.
Thanks.
Thank you.
Thanks.
Thank you.
Thanks. Yeah. If
Sir,
anybody has any
this node name is pipe
yeah,
dot by line. Pipe dot by line, sir. This package name is.
okay. I don't think I have it installed because I think it's a separate package, right?
Yes.
I don't have that installed. I will try to check it from my end also, like download it and check it.
Yeah, his name is
Uh,
pipe dot by line. This code name.
yeah, I will share the script with you so you can download it and check it in your system as well. Like since you have the node, just connect it with the curve output, the line it is creating at the end. Mm, From there,
Sir, this package name is MEP Power.
MEP power, yes. Okay, I
Yes,
will
sir.
download it and try it. I don't have that package with me at the moment. Yeah.
And sir, also this question, you make this line is you solve how problem. If we need this line curvy line, then how will you make, sir?
So the curve, like the lines, if you like curve as in that object is curved in itself, like curvy line as in you're saying that tunnel is curved, the roof of the tunnel
Yes,
is
sir.
curved.
Some area
Yeah.
is curvy, some area is straight, some area is 25, 30 degree like that, or 10%.
So if I
Actually,
share my
Curvature.
when
screen, yeah, yes. If I
yeah,
understand what you're saying correctly, uh, if you're saying this thing is curved instead of being straight, how I drew over here, you're saying this is like uh, like
yes,
something like this, right?
yeah.
Mm,
Actually, it will generate the same curve, right? Same
mm.
as yeah.
Yeah.
When the Dynamo run again.
So there is a node that generates a line on a surface, which is called ISO lines. Wait, ISO. switch to node view. So if I, instead of using the center point and doing it like this, what I can do is, I'm thinking I will take the face as the best surface, and I will take the
and
parameter.
parameter.
Yes. This is again, will be taking the center and see how it happens.
0.5.
So it should be possible to generate this line.
Uh,
Okay, it's coming as a straight. We wanted to follow the curve, right?
curves, yeah.
Yes, there is follow surface. It's possible to generate this kind of curves, like what you're talking about.
Uh,
It's
yeah.
possible to generate. Just have to find out the exact modifier that does it. Not rule.
Curve. So sweep.
Still not what we want. Mm, this I have to check and get back, but I think it's possible. Like either via ISO curves or something like that. It should be possible because it will give a coordinate system now. Like this is again something that I have to check and get back. Like I don't have a ready-made answer, but just checking. Yeah, like it should be possible to generate that. Okay, another thing we can do is, instead of selecting that, we can select the edge and use that.
Uh,
Like we can select this edge and then just offset it in a particular direction. Like just as a stopgap, I'm thinking, but
yeah.
offset the curve.
Edge.
Yes, tell me.
Distal. Yeah, it's okay.
Hmm.
So if we select the surface, we can get the
Yes. Yeah.
polycurves of the edges, right? Same
Yeah.
what we did now in the footing for the PCC, right?
Yes. Yes. Just give me.
Uh,
Yeah. Just 1 second.
okay, okay, no problem.
Hi. Yes.
Right.
Sorry, you were saying. Yeah.
Yeah.
Yeah. You were saying that. Yeah. If we get the surface, we can extract the curves from the as well. It's
Uh, yeah.
edge.
Uh, yeah. Parameters. So now we can offset these curves below or in the middle or whatever, because we know the exactly the width of the tunnel is 4 meters, so we can offset one of them in the middle, right?
Yes, that's what I was just thinking of doing as well.
Mm.
So if I offset it, offset the curve, and I need to give it a direction, which direction I want it to be offsetted. Just do a factor. So this will just give us a direction in which to offset it, whether X, Y, or
Mm.
Z, like how to move it. So
Okay.
so this I can do multiple ways, but I'm just doing it
Yeah.
like this at the moment. What happened? I need a distance. Okay. Number.
Uh, Z axis we can give minus.
So the thing is, yes.
Yeah, it's
So the
offsetting.
curve will get offset in the plane it is on. So if
Hmm.
I go switch to node view, like switch off all of this, not all of this. This all we don't need. We need what? Geometric view. So we have the perimeter curves over here. Okay. And then we are just offsetting it over here. We are offsetting all of them
Um, so if we say minus, so it will come.
on the opposite side. So if
Yeah.
I just
Okay.
use one of them, like instead of doing all of them, I took the curve right initially.
Mm.
So I can input that directly in and that will offset only one curve. So
Okay.
if I just select the edge, like from which direction I want to offset, now I go on over here and it offsets that one only. So if I know it's
This
4
one only.
meters, yeah, I can say 2000 and then offset it
Okay. Yeah.
8000, whatever it is, like 5000. I
Thank
can
you.
change
Thank
the
you.
value and try to get it. For this 50,000, I need.
And boss, if I need this offset, then how can we the same line which you make?
And then, yeah, with this line you have now, you can just what to say. Hmm.
Suppose I
Use the
need four pipe here, so I want just create same four pipe to this
yes.
reference of
So
this line.
yes. So if you want to do that, then what you can do is just get the start and the end point of this line.
Mm.
Like this curve you have, right? If I say use this curve directly into model curve, it will generate a curve for me in Revit. You can see I have a model curve over here.
Mm.
This one, right? And if I want to move it up and down, that also I can do. Say I want to move, don't want it at this direction. I want it a little bit below, so I can move it down using the move command. This you have to create and then try, like exactly the solution you are looking for, whether it meets your requirement or not, and then feed this in. It creates it at the bottom. So this is one way to do it, but this
When
is
we
very rough. You have to check it like and then make a solution to it. Yeah.
Yes, yes. Actually, when we have the curve, then we
Yeah.
can do anything. Like we can model anything on it, like
Yeah. Yeah. Yeah.
pipe,
Yeah.
beam, or whatever.
Yeah. Yeah. That's it. Yep. Thank you.
Thank you. Thank you. Thank you.
Thanks.
Thank you so much.
Thank you, sir.
Thank
Thanks.
you.
Thanks.
Thank you
If any,
for
yeah, thank you.
for your extra time. Thank you.
Yeah, no issues, no issues. Thanks. If anybody has any more questions, or else we would end the session. Yeah. Thank you, everyone. I
Thank
think
you.
we can end it
Thank you.
over here.
Thank
Yeah.
you.
Yeah.
Thank you.
Thanks. Thanks.
Thanks.
Thank you, boss.
Sagar, I think we can close it. Yeah.
Yeah, sure.
Yeah, thank you.
Yes, sure. Yeah, thanks.
Thank, thanks.
Mm.